Okay, so now we're going to go into the check your understanding for topic 5.2, which is the EVT, the extreme value theorem, the extrema, and critical points. So first thing we're going to do is the graph of f prime of x is given below. For which values does f have critical points? So critical points, if you recall, are when the derivative of the function is equal to 0 or the derivative is undefined. So it's really important that you know if you're looking at the derivative of the function or the original function. In this case, this is the derivative of the function. When we were doing the example in the previous video, we were looking at the actual function, and so we were looking at the slopes. But now we're not. This is the derivative, so we're looking at where the derivative equals 0. Happens right there and there. So it's equal to 0 at x equals 1 and x equals 3. And where is it undefined? So it's undefined right here because there's an open circle. So it's undefined when x equals 4. And so I've explained as I've been writing, have critical points, and explain. So one of the things we like to do with check your understandings is try the problems first. Now, I haven't actually told you how to do this, so it's a little bit hard to try the problems first. So when we look at, we need to make sure we're checking what are we given. When we're looking at a picture, are we given the equation, the actual function, and then we're looking at slopes. Are we giving the derivative? Then we're just looking at, hey, where's the derivative equal to 0, etc. Sometimes we're given the second derivative, and that gets a little more complicated. We will not talk about that one today. So this is a polynomial equation. We're asked to find the critical point. So to find the critical points, when this is what we're asked to do, set the derivative equal to 0 and solve. That is your hint. That's a hint for number 2. So we'll come back to that in just a minute. We'll do it together. But for right now, there's your hint. Sketch a function that meets the following requirements. Absolute max at the left, relative mins at, absolute min at, and an undefined derivative at. Okay? So we got to kind of remember what makes the derivative undefined. And so that's a little tricky. We'll get back to that. But the idea is absolute max is at the left endpoint. So that's the absolute max is somewhere over here. Highest at endpoint. Relatives and absolute min at 6. Smallest. And undefined at 4. So just kind of think of that. What do you need to do? Relative mins. Relative mins at -1 and at 3. Okay. So we'll come back to that graph in just a minute. Again, hints. Multiple choice, the function is continuous on and differentiable on. So continuous on the closed interval and differentiable on the open interval. Officially, derivatives do not exist at endpoints. So that's why it always says this, continuous on the closed and then the differentiable on the open, because the endpoints don't work for the derivative. If f is this and that's, which of the following statements could be false? We'll get back. Number 4 is the multiple choice, should probably be okay. All right. So now, if you haven't already paused the video and tried, go ahead and pause the video and try number 2. Okay. So the first thing we're going to do is take the derivative of g, which is 6x minus 8. Set it equal to 0. And x equals 8 divided by 6, or 4/3. That's the only critical point. You asked me to decide what's happening there. That's the only critical point. Officially, then I would decide if it's a min or a max there. This is a parabola. It opens up. Because a is positive. Right? Therefore, this is not a calculus piece of information. That's just something we know. So is this a min or a max? Good question. And again, we'll learn how to do it, how to figure that out soon. It's Thursday. Sketch a function from -3 to 8. So if this is, I'm going to spread these out a little bit before I actually do the sketch. So this is going to be -3 -2, -1, 1, 2, 3, 4, way too wide, 4, 5, 6. It's going to be off the paper a little bit. Break it out however what works for your brain. Just try to be consistent on interval size. -1 was important, 3 was important, and 6 was important. Highest at the right end, left end point, so up here. Undefined at 4, and then relative mins at -1. So let's go down, come, turn up. And then it needs to be have another relative minimum. Doesn't say what the max is. At 3, so we're going to go up and come back down, and then go up again, and then it needs to come down again so it can be the smallest here. It needs to do something funny at 4. So at 4, I'm going to have it cusp. I'm going to just change it to a line. So it'll be curve-like, and then we'll do a line. Oh, it didn't. It said relative. It didn't say undefined there. This one's undefined, which means it needs to be cusp-like. This one needs to be smooth. Okay? Something like that. Whatever works. Now keep in mind that you could have it right if you went like this. Right? As long as it's 6, it's the smallest. So there's lots of correct answers. This needs to be the highest. That needs to be the smallest. There need to be 2 other bottoming out points. And a cusp or sharp turn for the undefined derivative. Okay? If you want to see another image of that, so here's another version of that graph. See how it's very different than mine, but that's the idea. Okay? All right. Multiple choice. The function f is continuous on the closed interval and differentiable on the open. Again, not differentiable at the right here. Derivative is undefined at endpoints. So which of the following, if f of -2 is -5 and f of 1 is 4, which of the following statements could be false? There exists a c between -2 and 1 such that f is 0. Well, it's continuous from -2 to, well, it has to cross through 0 to get from there to there if it's continuous, right? So yeah, that's true. So it's true. So we're looking for the one that is false. Could be false. Doesn't have to be false. Could be false. So A is true. Make a decision, by the way, if you haven't already. This side. There exists a C where -2, between -2 and 1, such that the derivative has to equal 0. So which would mean that it would have to turn around somewhere in that interval. And so, thinking about it, at -2, I'm way down here. At -5, and then at 1, I'm up here. There's lots of ways to get there. I can take a slopey, curvy path. I can take a straight path. In no way does, on the curvy path, then yeah, my derivative has to be 0, but on my straight path, no. So this one could be false. There exists a C such that between there where it has to equal 3, yep, passes through. The same reason this first one has to be true. That would be the intermediate value theorem for both of these. There exists a C such that the derivative has to be 3. It's differentiable, has to equal 3. This would be, I think they're trying to get you for MVT. which we learned in class in live on Monday. And so let's check. Let's just do the average rate of change. So we've got 4 minus negative 5 over 1 minus negative 3, which is 9 over, negative 2. Brain going too fast. 9 over 3, which is 3. So yes, that one's true. This is MBT. There exists a C such that this would be absolute max. And yeah, there has to be. That's the EVT, extreme value theorem. So the only B is my answer. It's the only one that could. It doesn't have to be false because I could have a curvy path, but I could just go there straight. No reason to know that I have to turn around. So, yep, there you go. That's it. So B is the answer for 4. All right, we'll talk soon. See you guys later.